Okay, so I kept this first lesson very short because it is the first day after March break. So we're just going to ease back into it. I have made a little chart to remind you how far we've come. So in grade 9, the whole purpose of grade 9 was to learn about the line, which is the linear function, y is equal to x or y is equal to mx plus b. In grade 10, we were introduced to our first quadratic, which was the parabola y is equal to x squared. In grade 11, we're actually going to learn 4 new functions, but we're going to split them up. So we learned 3 functions this right now today. And then the 4th function we're going to learn when we do our exponential unit. So we're kind of splitting it up. By the end of grade 11, you'll know the square root function, absolute value function, rational function, and exponential function. And then in grade 12, you learn one last function for high school, which is the cubic function. Okay, so that's sort of the overview of what you've learned already and where you're coming from. I love this. I know it's like a waste of paper, but please appreciate it because it's so cute. Back in the day, we used to do this assignment where we would actually make you do like a dance based on function transformations. Don't worry, we won't do that anymore. But all the functions can sort of be described by hand movements. So if it helps, just take a look at the little dancing figure. And you actually are going to learn y is equal to sine x and cos x in grade 11 as well, but we don't include that in the chart. But anyway, super cute. Okay, so if you turn to the next page, we have our 3 functions laid out there. And for every function, what we're going to do is we are going to fill out a table of values. We're going to graph it, and we're going to talk about the domain and range and some special characteristics if they exist. Now, the thing with these new functions is the table of values is going to be slightly different depending on which function you're talking about. So you know how for the line, we would use -2, -1, 0, 1, and 2. And then for the parabola, we would just use the step pattern. Well, for these new functions, every function has a slightly different table of values that we're going to talk about. So let's start with the square root function, which is the square root sign with an x underneath. Now, we don't have calculators, right? So if we're making a table of values for the square root function, what kind of numbers do you think we should put for our x values? Yep, Sarah? Yeah, we probably want to include perfect squares so that when we take the square root of them, we get a nice whole number. So I've already written it down for you. The numbers I always want you to pick for a square root function, if you want to make your life easy, is 0, 1, 4, 9. And if you had enough space, you could also pick 16, 25. But usually our graphs go from 10 to -10. So those are the numbers I always pick. Okay, now to complete the table of values, we have our x values. We're just going to input it into the function and see what we get. So when x is 0, the square root of 0 is going to be just 0. The square root of 1 will be, the square root of 4 will be, and the square root of 9 will be 3. Okay, now to graph this, we're going to put 0, 0, 1, 1, 4, 2, and 9, 3. You're going to make a nice smooth curve that's going to look like, oh gosh, you know what? I'm going to move this over. That's not bad. So it kind of looks like a sideways parabola and only one part of it. And remember, once you're done drawing your function, for your test that you're going to get back, the quizzes you're going to get back today, I did write for a lot of you. Actually, no, that was last time, right? I wrote label and arrows. I didn't take off any marks, but for the unit test next week, I will. So make sure you put arrows on. For this function, it's just one end of it, but for a line, it's both ends. For a parabola, it's both ends. And then make sure you always label your graph. It doesn't matter where you label it. And I always just go back to the original. So in this case, it's f of x is equal to square root x. Okay, and just for practice, because now we know how to do this, we are going to also talk about the domain and range. By the way, that was really well done on this assessment. I feel like you guys really got good practice because I was pleasantly surprised by how well that section was done. Okay, I'm going to write the domain and range in the proper form that we have learned. So the proper notation, we start with a squiggly bracket, and your domain are all of your x values. So this is the set of all x values such that, sort of the short form of that. And then for this graph, For the domain, you're basically thinking about how far left does it go, how far right does it go, side to side. You can see this graph starts at the number 0, and then it goes on forever in the positive direction. So how would you describe that using a condition? Marzu? Yeah. So to describe the x values, it's every value greater than 0, and also including it because we have a closed circle, not an open circle. And then we end off by writing x includes all real values. And the only time you don't put x includes all real values is when you have a scatter plot. Other than that, anytime you have some sort of straight line, it'll always be x includes all real values. Okay, now for the range, again, for the range, you're looking top to bottom. You're figuring out where the graph starts and then how high up it goes or how low it goes. You can see that this graph starts at 0 and then it goes on forever in the positive direction upwards. So how would you describe this graph, Sarah? Yeah, so we're going to say the set of all y values such that y is greater than or equal to 0, and y includes all real values. Now, I know I keep showing you the proper notation. Really, the most important part is the condition. So if you struggle with the stuff that comes before and after, just make sure you get the condition right, because really that's the most important part. And then does this have any special characteristics? No, it really doesn't. Just keep in mind for the table, I'll just write table of values to remind you that whenever you are making a table of values for this function, you want to pick perfect squares. Sarah? So what I just said while I wasn't on the microphone is that these are all our parent functions. So there are original functions before we do any transformations. And then for the rest of the week, we're going to learn how to do transformations on these. Okay, number 2, this is our absolute value function. You may or may not have ever seen this before, but an absolute value sign is when you have two vertical lines surrounding your x. And the special characteristic about the absolute value sign is, does anyone know? Does anyone know what the absolute value sign does? Marju? Yeah, so if you've taken physics, then you know it's the magnitude. It basically means anytime you input anything inside of the absolute value sign, it always comes out as positive. So for example, if I have x to be -2, when I put in a -2 over here, it's going to become +2. So it's sort of like this magical gateway that changes all negative numbers into positive. And what does it do to positive numbers? Nothing. It just keeps them as positive. So when I put in x is equal to -1, it's going to become a +1. When I put in x is equal to 0, it is a 0. And then all positive numbers stay the same. So it's just going to be 1 and 2. Yeah, it's not like it changes the sign. It just stays the same. Okay, so if we were to graph this, make sure for this one you guys have rulers. I'm just going to pause so I can do this without struggling. Okay, so hopefully you guys got the shape I got. An absolute value graph always looks like the letter V. Make sure you use a ruler and don't make it into a parabola. So it should not be curved. It should be like two lines that make the letter V. For the domain for this graph, what do you guys think? You notice the lines are going in both directions, always in either direction. So it would be exactly. So the domain is a set of all x values such that x includes all real values. How about the range? It has a starting point and then it goes on forever. Yep. Good. So the set of all y values such that y is greater than or equal to 0 and y includes all real values. And under special characteristics, we'll just write what the word absolute value means. So any number inside the absolute value sign is always positive. And for the table of values for this one, it doesn't matter what numbers you pick. You can pick anything you want. There's no specific thing like it was for square root. The last function is definitely the trickiest one, and that's because we're going to be introduced to something called asymptotes, but also filling out the table of values, the math can be a little bit, not tricky, but different. Okay, so let's try this one. I'm going to use yellow for this. You're going to notice that for the rational functions, which is just 1 over x, it's a fraction where the variable is in the denominator. I've picked the numbers -2, -1, -0.5, 0, 1/2, 1, and 2. Now, you don't have to really pick the halves, but I just find that picking them makes the graph shape look really obvious to me. And so I think that it does help when you're graphing. Okay, so I'm just going to go to the side over here so we can figure out what exactly is happening. Our function is f of x is equal to 1 over x. And the very first thing on my table of values is -2. So I'm basically saying when when x is -2, what is my y? That's just going to be 1 over -2 or -1/2. So I'm going to come back here and I will write down -1/2. For the next one, my x value is -1. So again, I'll do the same thing. F of -1 is 1 over -1, which is just equal to -1. Okay, so this is my function. I'm just putting in all the x values and solving. Sarah, you definitely don't have to show your work for this. And in fact, after this, now I'm probably not going to show it. Oh, actually, no, I want to show it for the last one, which is a fraction. Okay, so for the next one, we have f at -1/2. You have to be careful with this one. This is like saying 1 divided by -1/2. Rahima? -1/2, -1/2. Okay, so take a look at this one. You have 1 over -1/2. You have a number divided by a fraction, which means this is kind of like writing it as 1 divided by -1/2. And that's the same as 1 times -2 over 1, which is going to simplify to give us just -2. Now, you don't have to show any of this work. You can actually, we're going to do it so many times that it will become sort of, you'll end up memorizing it. But if you wanted to know how we get that answer, it's this way. We put a fraction of the denominator, take the reciprocal, and you end up getting -2. So over here, we're going to have -2. I said I wasn't going to do any more, but I am. Look at what happens when we put f of 0. What is 1 over 0? It's not a 0, it is an error. Remember, 1 divided by 0 gives you something that is undefined. And that's really important because that means that for this function, we're going to have something called asymptotes. And this is something you haven't seen before because we've never had a function that had an asymptote. I will define what an asymptote is. I'll also show you how to write it down, but let's finish the table of values and then we'll come back to this. Okay, so what am I going to write for that? I'm just going to write undefined or UND or just leave it blank, doesn't matter. Do the same thing for all the positive numbers. So 1 over 1/2 is going to give me 2, and you can actually work it out and see how you get that. 1/2. Okay, so the most unique feature about a rational function is it has 2 asymptotes. What is an asymptote? An asymptote is a line where a curve gets really, 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 really close to it, but it never ever crosses it. And I'm going to say that with a big asterisk because when you get to grade 12, you're actually going to learn it can cross it sometimes. But for now, we're going to think that for an asymptote, your curve can never go past it. And just remember in grade 12, if I have you again, we're going to learn something completely different. But for now, that's what we're going to remember. For the parent function of the rational function, we have asymptotes on the actual axes. And the way you're going to show that is you're going to make a dashed line using a ruler. So I don't have a ruler. I'm going to try my best, but you're going to basically make one dashed line going like this down the y-axis. And then you're going to make another one going up the x-axis, or across the x-axis, I should say. Okay, so we have drawn two asymptotes. We're going to label them. Make sure anytime you draw an asymptote, you always label it. The one that goes up and down is known as our vertical asymptote. You can use a short form of VA. And in order for us to figure out the equation of that line, we just look at what axis it's going through and what number it's going through. So it's going through the x-axis at 0, which means the equation is x is equal to 0. It's kind of like figuring out the equation of a vertical line. You look at the axis it's crossing through. So it's crossing through the x-axis at the number 0. The one going side to side is known as our horizontal asymptote, HA for short. And again, to figure out the equation of that, it's going through the y-axis at the number 0, which will be y is equal to 0. Now, this is only true for the parent function. Like I said, this week we're going to learn transformations, and that means our asymptotes are also going to move. But for the original parent function, the asymptotes are always at the x-axis and the y-axis. All right, let's go ahead and very carefully graph this. You are going to have to estimate the halves. Just try your best to do that. And the shape of the rational function is pretty unique. It looks something like this. Oh no, that's so messy. Okay, hold on. Let me try to do this. That's a little better. What it's really supposed to be is it's two curves that are basically hugging the asymptotes, but they're never going to cross through them. So they're going to get infinitely close to the asymptotes that I've represented in the green dashed line, but they're never actually going to cross them. They'll just keep getting closer and closer and closer and closer, and that's it. Okay, you want to make sure you have 4 arrows, one on every end of the curve. And you want to make sure to label it. So it's y, oh no, sorry, f, we're using function notation now. So f of x is equal to 1 over x. What do you think is the domain in this question or in this graph? It keeps going forever in the right and the left, but there's one number that it's never going to actually hit. And what is that number, Sarah? Yeah, so the way we write the domain and range for the rational function is we write the set of all x values such that x is never going to be equal to 0, and x includes all real values other than that. The same thing for y. So when you're going up and down, what's the only number it's never going to actually hit? Yeah, and so another way to think about it is whatever the asymptote is, that is the number that your graph is never going to cross. So in this case, it's going to be the set of all y values such that y cannot equal to 0, and y includes all real numbers. And to end this question, we will just write a short note on what exactly an asymptote is. So a line that a curve gets closer and closer to, but never touches it or crosses it until you learn that it does. For now, this is our definition. Yes, dashed lines. Yes. Okay, so review. We did the square root function. Make sure you use perfect squares for that. The absolute value function, just remember any negative number becomes positive. The rational function, you're probably going to have to spend the most time reviewing. It has asymptotes, it has 2 curves, and the table of values is a little tricky. But really your only homework for today is practicing these new functions. And to help you do that, there is a handout A. And for that handout, you're basically going to be graphing functions. So for question number 1, it says graph each pair of functions on the grid below. You don't have to find the point of intersection or anything. You're just practicing graphing. So the first one is, I just wanted to give you a little throwback. These are both lines. So you're just going to practice drawing your lines again using y is equal to mx plus b. And then these are parabolas. And then for question 2, you're actually going to graph the pairs of functions and also see where they intersect. And this is where we're getting into our new functions. So we have a line, and then this is the square root function. And this is our rational function. This is our absolute value function. Okay, so you're basically going to graph for the question number 2, you're going to graph them on the same graph and see where they intersect. I have included the answers at the bottom for all of them, including the points of intersection. And of course, if you need more practice, just grab a grid paper. I have some on the side and just practice as much as you need to. Marzu?